received this with, you can see a bunch of squares. I used almost exclusively emojis for my graphics because I've gotten caught using other graphics I shouldn't, and they aren't showing up, so my apologies. Let's see here. All right, automated testing for industrial control systems. You're really lucky because you're going to get a double dumpster fire today. One of them being the topic itself, testing industrial control systems, and the other, this is my very first Ignite talk, so you're going to see me panic every time the slide changes. So here goes. The purpose of my talk today is to scare the living crap out of you. The way I'm going to do that, there are systems running in your modern world today that affect everything you do that don't get tested automatically. I'm not talking about validation rules in e-commerce. I'm talking about industrial control systems. What are industrial control systems? They control everything in your life. They control traffic lights, HVAC in this building, chemical plants, pipelines, refineries, you name it. They're everywhere. So how does an industrial control system work? It starts and ends in the physical. We have physical devices such as temperatures and tanks and water. We may read those conditions. We run into two squares there, which is supposed to be a computer. That computer controls a valve. Those valves then can control the way the system works. Then we have humans that are involved. Holy moly, this is going to be really hard. Then we have humans that are involved that want to change set points and want to do things in this control system, so that makes it really complicated. Finally, we have two squares, which is supposed to be a safety interlock, which overrides anything the control system wants to do to make sure the system is safe. We test all these things by hand. And now this is the so in a small facility, you may have up to, say, 250 valves. Each of these valves, you look at it, you may need about 24 tests to get total test coverage. So that's 6,000 tests you may have to run for a small facility. But hey, it's not so bad because we have the object-oriented principles. So we bring that back down to 24, but then I have to add back on all the different design time attributes such as timings and delays, things like that. Now we have to represent the whole test space with scientific notation. And there's absolutely no way we're doing this by hand. So what do? We have automated testing to the rescue. Everyone does this, right? We write some gherkins, we run it through some cucumber, everything's rocking and rolling, it triples, no big deal, no fine, it's all automated. Problem is there's a massive barrier. And that barrier is a language barrier. Hey, my graphics. So we have no modern languages in industrial control systems. We have things like ladder logic, which is derived from electromechanical relays. We have function block, which is color by numbers for things that can blow up. Now the most modern thing we have is structured text, but you can see it's straight out of the 90s. So what is the state of the art in industrial control system testing? The state of the art is we write a test in Microsoft Word, we print it out, we execute it by hand, we record the results by hand, and we turn it into someone and say, hey, everything's good. This is the way General Motors did it in 1969 when they installed the first industrial control system. It's the way we do it today. But hey, I know you only do that for little systems, right? Wrong. I've been doing this for 20 years. Huge pharmaceutical, big dangerous chemical, and nuclear facilities that a number of my friends work in. I can tell you without a doubt, every one of them is tested by hand from end to end. And that was a picture of a lot of paper. In one chemotherapy facility we executed between 15 and 20,000 pages of testing by hand. So I've been complaining for about 13 slides. What about a way forward? How are we going to do this? So a friend of mine and I, we've come up with this idea. Can we do unit testing for automation systems on our way to something like a CI/CD pipeline? So we have a chance here. We can't write tests in the languages of these systems because the language is too low level, the memory is too small in these devices. Well, we have a protocol, OPC-UA. It's open source, it's cross-platform, we have a lot of clients. That's good. The next thing is we got to come up with a language. How are we going to talk about this? This is where we've fallen in love with behavior-driven design. What's great about behavior-driven design, it's a very natural language, and it looks a lot like how we write tests today. Do people care? I surveyed my professional network. People ranging from senior principals at huge biotech companies to the guy who handled radiation monitoring at Chernobyl. And without a doubt, across the board, everyone said that is a spectacular idea. We have to have it, do it now. So there's no point in doing it if there's not a lot of benefits. Here's an anecdote. A 25-year veteran from the pharmaceutical industry. In a pharma facility, it'll take on average 1 to 2 years to start these facilities up. He thinks if we do automated testing for these facilities, we can reduce that time by 30%. That means that we're saving lives earlier. So what am I talking about? I want to build a CI/CD pipeline for delivering industrial control systems. Today I'm talking about the middle. We've got some interesting work going on in the beginning. So thank you for giving a few minutes to the son of a cardboard box salesman from Alabama when all his emojis went crazy. This is something that's really important to me, and now I hope after hearing what a mess this is and what kind of opportunities there are, it's something that's important to you. Thanks.